different types of experiments generate different probability distributions. In today's video, I'll talk about binomial probability distributions. This is Senior Hannington, your accounting tutor. Now, binomial probability distributions, this is an example of a discrete probability distribution. In such experiments, there are only two possible outcomes. For example, tossing a coin. Every time we toss a coin, there are two possibilities. Either the head or the tail. The answer in a true or false question is either a true or a false. A product is either accepted by the quality department or not acceptable. So these are all examples of binomial experiments. A drug is either effective or ineffective. That is also an example of a binomial experiment. A college graduate applies or does not apply to a graduate school. All those are examples of binomial experiments. So there are always two possible outcomes in such experiments. You need to know the properties of a binomial experiment. As we have seen, there are always two possible outcomes. There are always two possible outcomes. The probability of the success is the same on every trial. The probability of the success is the same on every trial. The experiment consists of n repeated trials. The trials are independent. In other words, the outcome on one trial does not affect the outcome of the other trial. Those are the properties of a binomial experiment, and they are a must-know. Now, to construct a binomial probability distribution, we must know the number of trials. We have to know the probability of success on each trial. Now, in a binomial probability distribution, if you're to calculate the probabilities, we use this formula. Probability of a binomial random variable x equals to n factorial over x factorial times n minus x factorial. Then we multiply all that by the probability of success, which is p power x times the probability of failure, which is 1 minus p power n minus x. We need to know what each of these letters stands for. N, that is the number of trials. X, that is the number of observed outcomes. P is the probability of success on each trial. Then 1 minus P is the probability of failure. Of course, we need to know the summary measures of a binomial distribution. That is the expected value or mean, the variance, as well as the standard deviation. Expected value is computed as your n times the probability of success. Then the variance is the expected value times the probability of failure. Standard deviation, that is the square root of the variance. I have an illustration here, which I can use to see how we can apply the formula and also how to come up with the summary measures of a binomial distribution. A binomial random variable x is defined as the number of successes achieved in the n trials of a binary process. The binomial distribution for x shows the probabilities associated with the possible values of X. Of course, before we discuss the binomial distribution, one thing we need to know is that we must always ensure that the experiment satisfies the conditions of a binary process. Of course, which is a particular type of experiment, named after the person who first described it. And that was a mathematician known as James C. Barnori. Of course, in such a process, you find that it will consist of n independent and identical trials of an experiment, such that on each experiment, as we have seen, there are only two possible outcomes, and these are labeled as success or failure. And of course, the probability of success and failure remains the same from trial to trial. So here, they are asking you to explain any four properties of a binomial experiment. Those properties, we have already looked at them up there. So you need to know those properties of a binomial experiment. Apple products have become a household name in America. This is our scenario, with 51% of all households owning at least one Apple product. Apple products have become a household name in America, with 51% of the households owning at least one Apple product. What is the probability that 2 in a random sample of 4 households own an Apple product? We need to find out the n, and as we say that n is the number of trials. N is the number of trials. So I'll copy our formula of calculating the probabilities under a binomial distribution case. So this is our formula, which we can use in such a situation where we have a binomial experiment. So we need the P, which is the probability of success, and that is 0.51, because they have told us here in the question that with 51% of all households owning at least one Apple product. So our P is 0.51. Then 1 minus P, the probability of failure, equals to 0.49, which is 1 minus 0.51. Then N, number of trials, equals to 4. Then X, the number of observed outcomes, equals to what? X equals to 2 in such a situation, because they're telling us that what is the probability that 2 in a random sample of 4 households own an Apple product. So this is the formula to apply for us to be able to calculate that probability. So I'll say probability of X equaling to 2 equals to n factorial. N factorial, that is 4 factorial. X is 2, n is 4, X is 2. The probability of success is 0.51 power X, which is 2. Probability of failure is 0.49 power n minus X. N is 4, X is 2. That will be power 2. That will be power 2. So we come probability of X equaling to 2 equals what? Of course, you can press your calculators, but me, I have 0.3747. That is the probability that 2 in a random sample of 4 households own an Apple product. What is the probability that all the 4 in a random sample of 4 own an apple product? In this case, the probability of success remains 0.51 because it is the same on all trials. Your probability of failure still is the same, that is 0.49, and the number of trials equals to 4, x, the number of observed outcomes equals to 4, because they are telling us that all the 4 in a random sample of 4 households own an apple product. We still use our formula of calculating probabilities under a binomial experiment. Probability of x equaling to 4 this time equals to 4, which is n factorial over x, which is 4 factorial into 4 minus 4, because x is 4 factorial, times 0.51 power x, and your x is 4, times the probability of failure, which is 0.49 power n minus x, which is 4 minus 4. So this probability equals to what? Let us see the probability. So probability x equaling to 4 equals to what? The probability of x equaling to 4 is 0.066677. That is the probability of x equaling to 4. That is the probability of x equaling to 4. That is the probability of x equaling to 4. In a random sample of 100 households, find the expected value and the standard deviation for the number of households that own an apple product. They want us to calculate the expected value. And I told you already that expected value, which is EX equals to NP, And our N in this case, they're telling us that in a random sample of 100 households, so the number of trials in such a situation will be 100. So we have 100 households. So this will equal to 100 times the probability of success, which is 0.51, giving us 51. So that is the expected value. Then, of course, they also want us to calculate the standard deviation. But before I calculate the standard deviation, let me first calculate the variance. Variance equals to NP into the probability of failure. Our NP is 51 times the probability of failure, which is 0.49. And this gives us what? 24.99. That is our variance. If I want to get the standard deviation, standard deviation. This equals to the square root standard deviation this equals to the square. This equals to the square root of our variance. I want to see the root. Let me just go up here. Copy this. Standard deviation, square root, the variance. This equals to our square root of the variance. And the variance is 24.99. 24.99. And this gives us standard deviation of 4.99. So that is our question about the binomial experiment. That's our question about the binomial experiment. We have seen that in a binomial experiment, there are two possible outcomes. That is the success and the failure. And we have seen that the probabilities of success and failure remain the same on each and every trial. On each and every trial. So that is binomial probability distributions. We have seen how to calculate probabilities under a binomial experiment. We have seen the properties of a binomial experiment, and we have also seen how to calculate the summary measures under a binomial experiment. In my next video, I'll talk about the Poisson distribution. Please subscribe to my YouTube channel, Senior Hannington. Share the channel link with your friends such that they can also benefit from my content. Thank you for watching. Bye-bye.